thing on. Oh, right.
And I'm now going to restart the recording because otherwise you'd just watch me type up the polls before the session started. If you haven't already, it'd be wonderful if you could sort of say who you are and where you're from in the chat channel. We've got a number of people from a number of different countries. So thank you very much. It's towards the end of our workday here. And I know for others of you, it's at the start of your workday, or actually for those of you who managed to get out of bed particularly early, it's before the start of your workday. We have 3 panelists today, as well as somebody who will be monitoring the chat. So Amy Griffin is my co-host from RMIT in Melbourne, currently joining us from a parking lot in her car. And this is potentially one of the ways of being resilient in GIS education at the moment. So we have 5 panelists from a number of different locations. Unfortunately, our first panelist, Inesha Mazzini, is is unable to join us with video because the connection isn't particularly strong. So she'll be writing her comments into the chat and we'll be relaying them as required throughout. She's joining us from Solomon Islands, the National University there. Our second panelist is Dr. John Lowry, who is also in Aotearoa, New Zealand, but formerly was working in Fiji. So he's currently in Massey University. Our next panelist then is Alec Praziato, or Prastios, apologies. I took down two versions of his name, the one I guessed, and then forgot to update it with the right one, who's joining us from Indonesia and Bogor Agricultural University from the Department of Forestry. Unless I've got that wrong. And then we've got Andrew Fletcher, who's joining us from Queensland University of Technology in Australia. And then finally, Naru Tsumida, who's joining us from Kyoto University in Japan. So as I mentioned, Amy will be monitoring the chat, so feel free to send some questions through. I'll also be putting up a few polls throughout the session, just to get a bit of an idea of where people are thinking and what they're starting at. So if you have a chance, if you could vote in the poll at the moment, we've got 71% participation rate. I haven't done a lot of these in my class, and that's it, but the few I have done, that's actually quite good. So we've got an engaged and interested audience. If you have any problems in terms of the sound, or if there's something you didn't quite catch, please make use of the chat, because I said we've got someone monitoring it for the session. So let me slow down a moment and just say we're covering 4 different questions. We appreciate at the end, we'll be asking you if you want to turn on your mic and actually say something, but while our panelists are speaking, we'd appreciate it if you kept your mics off. We'd also appreciate it, as I'm sure you are, because the GIS community is wonderful, that we treat each other with respect. And if you have something that you disagree with, please approach that in a respectful manner. We didn't have that problem the last time, but I've just been at a conference where they had a code of conduct at the start and it sounded like a good idea. So first up, our first question is, how does GIScience Education interact with information and communication technologies, ICT, and learning technologies? And Professor Prestillo is going to be our first panelist who's going to comment on that question.
Thank you very much, Merit. I'm Lili Budi Prasetyo from IBB University. Yes, before I answer the question, I would like to tell about how we teach GIS in our campus. That's why you will understand my positions. Yeah, before the COVID, we are delivering course using face-to-face in a conventional GIS lab. But also we also providing some materials in the learning management system, LMS. So the student can have a material so they can prepare before the courses. And then after COVID, the lockdown, then we are delivering the courses through online systems. That is a very important experience during the pandemic of COVID. And of course, yeah, we are struggling hard to prepare the material to delivering the course of GIS. And it's very difficult considering there are a lot of, internet problems, internet issues, bandwidth. And also when the campus is locked down, most of the students came back to their hometown and somehow they have no any access to internet. That's why it's very difficult to deliver GIS in such kind of situations. But luckily, by step and step, we finally can adapt the situations, and now we are delivering full online courses. That's also the first experience for us. And we have two type of student. One is bachelor, and the other is in postgraduate. And within the undergraduate, we are mostly technically understand the GIS mapping, GBS. But in postgraduate, we are delivering how to use the GIS for the problem solving in the field. That's why we have difficulties how to practicing distance learning, online learning when we have no any chance to go to the field. That is the difficult. Yeah. So far, this is my position. Thank you, and Mary, please.
I'm sorry. Oh, thank you. And what would you say? Oh, sorry. Let me open that up to the other panelists then, in terms of their responses to that. Do you feel that the sort of the issues with internet is something that is shared? If I go to John, if you'd like to speak next, and then I'll move on to the other panelists.
Yeah, definitely. I think in some parts of the world, internet is a problem, but in other parts, obviously it isn't. So it's kind of depends on where you're from. From what I gathered, it can be a problem where Lilik is from. In terms of software that we work with, I think that if the software can, I think maybe a question that I would have for people outside of, say, New Zealand and Australia is whether students have the hardware that they need in a distance situation to install, say, QGIS on their own laptop. Is that a problem for the leak or other people, and that's kind of not internet related, but it's still technology related, and it's a question that I might pose to everybody, if that makes sense. In other words, do most of your students have a laptop that they could install a QGIS on? That doesn't require internet connection.
Yes, sure. Yes, that is what we are facing. So somehow we need open source software to delivering uh, the course. But somehow for the graduate, postgraduate student, it is a bit difficult just because usually when we are delivering face-to-face course, somehow we spend 2 nights, 3 nights in the field uh, to explore the capabilities of GIS in kind of a small project to solve the problem in the field. And it is it is difficult how to give such kind of background to the student, how to use the technique, how to use the somehow we cannot explain during online meeting. Yeah, this is my difficulties. Yeah.
So the problem is with online meetings primarily.
Yeah. Usually, we delivering course face to face, and we together go to the field and giving explanations about the how to get the data, how to get the sample, how to get the biophysical properties of the environment, of the landscape. Then they go with their groups and then decided how to use the GIS for uh, real problem in the field, and that is cannot be cannot be delivered using online system. That is yeah, we lost such kind of stations.
I see.
Yeah, I don't know in other universities.
I'm just going to open the floor a little bit. Naru, would you like to comment on what the situation is in Japan? Because I know I'm just monitoring the chat here, and Amy's put in that in Australia there's connectivity issues, and Annette Burke has agreed with her. And I know in New Zealand one of the things we had, like sort of crazy experiences during lockdown, where students would drive into campus and sit outside with their laptops in order to use the Wi-Fi because the connectivity at home was difficult. So I know I'm just wondering if you're experiencing similar issues in terms of the problems with implementing GIS technologies in Japan.
Yeah, thank you. And we have, yeah, obviously we have the same issues, but basically many, in my cases or in our university cases, many students from rural side then join our university, and it means that they are living by themselves and they have to rent a house, and then they have to contract with the Wi-Fi, but the Wi-Fi, the internet, it costs a lot. So some people just rely on the cell phone connections only. So if you connect it to the Zoom or some online materials, the connections costs getting so expensive. So that's a quite big issues in Japan, or especially in our universities. So some faculty or supports to rent the portable Wi-Fi system to every student, but the product is limited. The number of the product is limited. So it's somehow we can manage these situations, but still we have some issues related on the Wi-Fi. But the connection is relatively good. And if the students connect to the class, we can smoothly deliver our lecture to the students on the internet.
Sorry, better turn it back on my mic. Thank you very much. If I move over to Andrew, in terms of the technological support aspect, if you could elaborate on what you've written in the chat, that'd be great.
I'm sure all of the people teaching GIS run into similar problems. First semester this year, teaching, I try and introduce students to multiple platforms. I guess I'm in a slightly different position to most of the other people here, in that my unit is the only GIS unit in the entire faculty. So it's a single appendix, sort of, it has no prerequisites and nothing is required from it for future studies either. So I try and introduce students within the 13-week block to a range of software, but as everybody knows, if you're introducing the Esri suite, you need a PC to run. And I discovered that about 30% of environmental science students at my institution were Mac OS users, and so that, you know, chewed up about a week or a week and a half of my time, pretty much full time, just getting everybody set up so that they could actually use Esri products in some format for the semester. So I think, you know, it's a necessary evil, the ICT side of things. I've sort of structured my teaching to use student derived data for the most part, and so most things that students require for actual labs, etc., can be sent and received quite easily as email attachments and things like that. So that keeps the asynchronous side of things fairly robust. There's not many places where you can't receive an email with a small attachment on it.
Kia ora, thank you. Anisha, it seems like you've been able to join us, so welcome. I wonder if you wouldn't mind sort of commenting next, if you've got the connection sorted. Thank you, Andrew.
Thank you. Can you hear me?
Perfectly.
Yes.
Oh, sure thing. Okay, sorry, I'm a bit lost since the connection is a bit on and off.
Actually, I completely forgot that you wouldn't have actually been able to hear the discussion up until now. We're
So
just
we're
working
still
through the first question. Yeah, still on the first question, we're looking at how does GIScience education interact with information and communication technologies? And actually, I'm going to just quickly take this moment to summarize the positives, because we've been focusing a little bit on the problems and the limitations. And I think in the midst of all that, I think one of the things that's come through is there's some real key things that you can implement, and I'm sort of massively taking notes myself. So one of the things obviously is the possibility of looking at a range of software, specifically with a focus on open source, because of some of the restrictions they might have on Esri, first of all, being a proprietary software, but second of all, in terms of the PC issue. So obviously QGIS and similar software work on Mac OS and Linux. Some of the other things which I was incredibly pleased to hear about in Japan was the fact that they're making portable Wi-Fi available to some students. To be fair, that is something that I hadn't actually considered doing. And it's something that maybe we need to sort of hear within Vic or Tarangawaka, is to have a look at how that might work in certain situations and just sort of stock up. And then the other one then was the idea of using student-derived data, so that those are small data files so that they're easier to share. Now, obviously that fits with, and I know Andrew is interested in authentic assessment, so it fits with his approach to authentic assessment, meaning that the students are doing from data collection, and that obviously then fits back to Lilek's work in sort of those face-to-face field courses where the students can then actually create their own data and sort of then bring that throughout the course. So that's kind of where we've gotten to. So if you have any more questions or any more comments you'd like to make in general on the question, but if also with a focus on what sort of, how does it interact? Are there positive ones as well as negative? Because I think from the comments so far is that most people are here to try and get some tidbits as well as sort of ideas. Oh, we might have just lost Anisha again. I spoke too long, apologies. Sorry, I'll just give her a moment. Okay, the next time I'll stop talking quicker. Hopefully she'll be able to join us a little bit. Oh, here we are. Anisha, I'll get you to talk before I take up your bandwidth again.
So you can hear me?
Yes.
Oh, okay, sure. So we're still on the first question, right?
Yes.
Okay, before I comment on that one, I think I have to introduce the GIS learning here at CINU. First of all, it's not like a GIS program. At the moment, it's just a unit that was introduced into the Bachelor of Agriculture program and few of the environment programs in the diploma and certificate level. So it's like teaching a GIS unit in a different field. So we are not going deeper into more of GIS stuff, but just few basics, especially introducing vector and raster data and just how to use GPSs and inserting data into QGIS and how to create maps. Especially we are focusing on using QGIS at the moment because we do not have ArcGIS, but QGIS is okay because it's free and open source, so they can just install it from their laptops. But the far more problem is that not all of the students have access to private laptops, so they only depend on the lab for doing their GIS tutorials, and especially they can only access the GIS lab during our class times because the lab is like, for us at the moment, it's still the general lab where all students use. It's not specifically for GIS students only. So it's a bit difficult for them to, whenever they only find space during out of class hours, and they can access the lab to do the tutorials. So I think having, like, if they have their own laptops and install QGIS inside those laptops, it will be more easy for them to do their own work at their own times, not only when they come to school, but when they at home, they can also access QGIS software, especially from the laptop. So I think that's the problem with us here in CNU. I think that's it. I can contribute.
Cool. Thank you very much for your time. Right. So that's kind of the wrap up we've had. I want to go back to Lilek and just check in to see if there's anything you'd want to add, given that you got the start of this question. If there's anything specifically you'd like to add that sort of been bounced around.
Yes, Mary. The other problem is about the evaluations. So somehow we are facing a difficulties how we arrange, how we develop some kind of evaluation when student is using online system, just because cheating is somehow happen, and we cannot avoid that kind of activities, bad activities, but this is real and might be we can then even during the evaluation we already have a timing using Google Docs or LMS systems, but still we are very worried about the result evaluations. And then still when the end of the course is still I'm not sure whether we are delivering the course is understood or not. This is also present. Yes, it is all problem.
Cool, thank you. Yeah, I think as Amy's put a question on sort of the problem of exams and assessments in the chat, and I'd appreciate it if anybody has, this is a community, we're hoping that our other participants can share their experiences as well. Like, I think that's quite interesting. Somebody particularly has just asked, how do you provide fieldwork on GIS for forestry while the pandemic is still happening?
Yeah, we lost such kind of situations. We cannot conduct the field works in usually we divide it within small groups, 6 people, 5 people, to do small projects, and the project came from the data came from the field. So when the pandemic occurred, then we lost such kind of situation. Then did this, so the offline learning outcomes cannot be fulfilled just because we have no any chance to go to fields. That's a real problem, just because GIS is not the tools, but it's also can produce the data, primary data, for example, biomass, surface model, economic cover, and so on. So we cannot practicing in the field such kind of abilities. Yeah.
I think that's been relatively universal, and I wonder if anybody has done something in terms of dealing with the problems of virtual field trips, or sorry, of virtualizing their field trips rather than virtual field trips.
Yeah.
I'll leave that there for a moment, but I have a feeling sort of that a lot of our questions are fairly interconnected. But I'll just move on now to the next question in our series, and I'm sure our answers will sort of circle back. And that's specifically, how might a culture of sharing teaching resources help support resiliency in GIS education? And I'll just go to Daru first for that one.
Okay, thank you very much. I'm from I'm now from Kyoto, Japan. I'd like to talk something about the communication or sharing the resources, but it's not related to the COVID-19. I try to deliver one very nice example from Japan. So here we have a GIS education. It's delivering Japanese basically for the undergraduate level, but some teachers deliver the program in English for the postgraduate master course program. But I'm more talking about the undergraduate level education program delivered in Japanese, because most of the students from in Japan from Japanese. And then this, our GIS education implemented by the various disciplines from the geography, but civil engineering, but environmental sciences. That's because here in Japan, we have no geographic faculties. So many GIS related team or studies are scattered and fragmented. So we try to make like how the GIS education is to be united or connected to each other, the disciplines, across the disciplines. So one of the very nice research groups from Tokyo universities launched a GIS education project, which is supported by the governmental aid funds. And this project firstly reviewed a lot of case studies relating to GIS science education in Japan, because our GIS education is happening in many fields. And then they reviewed and evaluated. Then finally they built up one open access e-learning materials for GIS education, which is written in Japanese and hosted in GitHub, and then put the open license, the CC by SA4. So if you can read Japanese and can access to the online materials freely, then even the teachers can also utilize these materials and deliver the lectures using these materials to the student. Then the contents, it covers the contents from the fundamental principles GIS science. That's because it's aimed to the undergraduate level class. The fundamental from the fundamental principle GIS sciences, and the uses of the FOSS4G, including the QGIS, GraphGIS, PostGIS, and also the some like remote sensing technology and Python or something, some other things. Also, they also give some example to the application in natural science and disaster science and urban or regional planning. So this project launched several years ago before the COVID-19, but in these situations here, and this material is quite so useful because we are challenging to give some courses online, but now the materials is already online, and we can easily use these materials and edit some and then deliver to the class to the student. And one big note in the Japanese education system, and changed a little bit. Then GIS will be introduced in the mandatory high school geography subject in 2022. So now the high school teachers and university staffs try to prepare how to deliver the GIS courses from high school to the undergraduate level. So we are now, that's really start from 2022. So it means that all high school students will learn the fundamental GIS science and practice GIS in high school. So try to make bridge this content to the undergraduate level in university smoothly. We are facing a new challenge towards the resilient GIS science educations. So that's our next challenge for us, to how to deliver the online or the material sharing from teachers, not only the university level, but from the high school level to university levels. Okay, so that's it. Thank you.
Kia ora, thank you very much. I'm going to go with the order of people on my screen. So at that stage, the next person is John, if you wouldn't mind sort of commenting on where you are with the sharing of resources.
Sorry, again, please.
Yeah. So when I think of sharing resources with GIS, a lot of the work that we do involves creating GIS tutorials. And so to some extent, I think it's possible to share tutorials. And if there is a mechanism by which that can be easily done, sharing GIS tutorials is a good thing. Students, of course, prefers tutorials that are using data that they're familiar with, so from their home country, as opposed to tutorials that maybe are found on the web for the United States or Europe or someplace else. Certainly, that's the last resort. So sharing tutorials can be a problem, or can be good if you can tailor them to your own needs. But I think that maybe more important than tutorials for me would be sharing ideas about how to teach GIS. So if there were a blog or some other kind of web resource that GIS instructors could go to learn about how other people are approaching teaching GIS. So for example, how do you encourage students to interact while in Zoom discussing a particular topic? Or how do you teach modeling? Or how do you teach some other topic? So teaching methods, I think, and are just as important as maybe the sharing tutorials or data. Those are just a few thoughts.
Yura, thank you. Lilek, would you mind sort of commenting on your thoughts in terms of sharing teaching resources?
Yeah, it is amazing hearing the policy of from Japan's university that provide the learning.
It appears we've lost Dilek. I'll just move over to Andrew Fletcher then. I'm literally going with the videos that are as arranged on the top of my screen, and hopefully be able to connect back with Lilek in a moment.
Like the idea, I think Queensland in particular is recently, is rolling out GIS in high school in years 11 and 12 as part of the geography unit that will, subject that will go through high school. The trick that we have at my institution is that not everybody is required to have done geography in order to come into science, or even have done science to come into science. So we get a very variable baseline of students. Some have used GIS even in high school, and others have not at all. I think John sort of hit a point there, particularly at the start, or for people I suspect like Anisha and myself who have a very limited window to teach GIS, focusing on local, real relevant topics is very important, because particularly when students aren't say computer science background, there's a lot of just basic technical problems that crop up with GIS. ArcGIS is no longer responding and things like that. So having an engaging activity really helps a great deal with that. I think, the idea of how things are taught, I'm more than happy to share my materials with people. In the past, I haven't noticed that that's something that's easy to do, but I think it's probably because we don't have like a central repository or blog or something somewhere that's curated that we can put things to. It's usually you start searching for something that you've got a bit of an inkling that you might want, and you land on a resource that might be new, might be old, might be on a different software platform, and you translate it. Perhaps in between there, one of the notes that I made thinking about these topics is more generalized workflows, perhaps, that draw on global open access data sets. So I'm thinking Natural Earth, SRTM, or Landsat, things like that people can put together for their region, and then a series of little workflows, conceptual workflows that provide people with ideas where they could clip down a data set for their region or their interest and develop a workflow from that.
No, thank you. Anisha, if you can go, if you can sort of comment next, if you wouldn't mind. If there's anything you'd like to add.
Okay, sure. Thank you. Just want to comment on the part when Naro explained that there will be GIS introduced in high school. I think for us, like for the case in the Solomon Islands, especially for GIS students, they are mostly computer illiterate. So they have problems with navigating through the software and where to click next. And they also have problem reading the instructions, especially when doing lab tutorials. They can't tell which is which from the software and the lab instruction. And they also are not comfortable with their mouse. So the thing is, if it is introduced in high school, and then students get to start learning basic Microsoft. That's where the foundation is, because using taking GIS class is all about working on the software, especially using computers, and it's challenging when they are computer illiterate. They do not know simple tasks like how to create folders to store their data or something like that. So I think it's good that when it's introduced in high school, they choose from there and then start learning of the basics from there, especially basic stuff for like computing skills, and that's it. So when they come to uni and they choose the path, it will be more easy for them.
Cool. Thank you. I think it's an interesting sort of point you brought forward, that the idea of resilience in GIS education might not just be at the university level. It might be about sort of, you know, pre-salting our students and working with sort of across their education. I think it's a really nice theme to come out of this question. I think I've hopefully managed to get to everyone on that question. I'm just going to move now to Andrew Fletcher to ask to move on to the next question, to ask about how we can ensure quality and resilience GIS education. I know there's been a little bit of chat, our people have been supplying some thoughts in the chat as well on their GIS courses and how they've done assessments particularly. But if you'd like to comment on quality and resilience education, Andrew, that'd be wonderful.
Thanks, Mark. Yeah, it's a I guess there's a couple of levels of challenge here. One is the challenge of a sort of a global standard or something approaching a common set of skills that people would have. In that case, it's really a question of you know, making a set of competencies, I guess, around a particular level of learning. For Anisha and myself, as you know, single GIS units, we're looking to try and fit as much as we can into the unit that is, you know, very practical in nature. I suspect for other institutions, you know, Southern Queensland and UQ, where they have an entire degree, the focus can be on deep learning in particular topics for each unit. So that throws up some hurdles to a sort of a broad quality assessment. But I guess when I was thinking about, you know, quality and assessment of quality across institutions, it would be maybe a set of online curated problem solving exercises or activities. You know, there's a range of factors that have to go into that. My approach has been to provide or require the students to provide the data set. So every year, the data sets that are available to the students vary from year to year. It's which adds some challenge, but it means that every student will have to make those sort of complex data quality and assessment decisions themselves as they go through. And so they learn about uncertainty in location, uncertainty and errors in attribute entry and those sorts of problems that everybody likes to gloss over with GIS, particularly in undergraduate. levels. So perhaps having problem type assessments set at different levels or for particular skill sets curated online might be a way that people could compare their learning with others more broadly. So that's sort of my high level comment, I guess, on quality control. At the local scale, when you get thrown into a pandemic, global pandemic like we've had, we have to make changes. There's no choice in that. The workflows that I've developed for teaching can be conducted by the student alone. None of them have to be face-to-face, but that support element, so an online support element. I'm not sure for other institutions, but we had students leave from Queensland that returned to the Caribbean, to the UK, to the US and other parts of the world, and even between countries with good internet access, those support factors, just technical support for GIS, can be quite slow. They're much more tedious than being in a common lab or something like that. So yeah, I think, let me just check here. With regards to quality metrics, I think we're actually in a good place. It's why I have a love-hate relationship with ICT and computer science, because we get everything digitally provided. So we've got a complete record of learning. We've got an access to that information. It's just a question of how we sort of manage the impact across that change. For us, we do have an exam. The students often say they don't feel that they need an exam because they feel like they develop the skills and can apply the skills as they go. But for mine, I keep the theoretical component to 10%. So that's 10% of the total unit marks. Sits in a sort of a short answer type question, testing understanding, and then 15% in a problem solving exercise. I'm teaching environmental science, environmental engineers, people like that. And so I give them problems that they could reasonably expect when they leave and enter the workplace. And that's, the goal is, if I give a student a high grade for the unit, I'm thinking that student, based on what they've presented, going into the workplace, would be able to start working effectively using GIS to solve problems on day one, pretty much, of their new employment. So, by keeping that as the focus, I think the quality control side of things tends to handle itself, because you build assessment items that test their ability to understand and think. Sorry, probably blabbed on too long.
No, not at all. Not definitely not at all. I particularly like our pointing out of the idea of learning metrics and the fact that we've got more control over when we've got more of a record of when the students are engaging, and sort of for how long and things like that that we do in the digital environment that we're not actually getting necessarily in the classroom. So thank you very much. I wonder, just to circle back to that, I wonder if you had a thought about the sort of the quality of teaching. So we kind of focus on the quality learning, which is something we should be doing as teachers, rather than just simply what we do. But I wonder if you had anything to sort of add in terms of the quality of sort of good practice in GIScience education, sort of things like benchmarking, curriculum design, that kind of thing.
Yeah. I did have, so our institution doesn't have high attendance rates at face-to-face lectures in particular. 30% is not a bad turnout for lectures. So a lot of students are watching the recordings afterwards. I do find it difficult because, as I said earlier, a lot of our students may not have even done science, may not have done any science since grade 10, when they land in the institution, and this is a first semester, second year unit. So yeah, I like to include interaction in the lectures. So I include physical props for things like time zones and decimal degrees or versus degrees, minutes, seconds, and other things like that. So those things have had to become an online activity, and that is a good deal more difficult. I guess this year we've had no real feedback on the teaching, so I'm not sure if I did okay or not. But I did note that generally the modal sort of grade was down by about a unit, a single unit in a seven range for this one. So I think given that it's a pandemic, that's probably pretty good. We didn't have a high fail rate, but yeah, I'm unsure just yet as to how my teaching has been. And I think my learning side got through, but I may have done that simply by sheer bloody mindedness rather than excellent teaching.
You sound like somebody who reflects on their teaching, so I have no doubt it's appreciated by the students. If this time I'll go to Naru, would you like to sort of comment on the idea of ensuring quality in GI science education, both in terms of learning and also in terms of teaching?
Me?
Yes, please.
Okay. Yeah, it's quite hard. It's very difficult questions, and I have no good answer for that. But if talking about a high level course like advanced master course level or GI science classes, I guess we might not yet, but we might introduce like a reproducible GIS processing analysis or something like that using the code like a Python or R, and then if we can teach and we can use such kind of the techniques, probably we can do the same things using only code. So we don't have to prepare the QGIS desktop environment or some other things. So that might be one of the challenging topics to ensure the quality of the GIS science. But probably it might be it must be the high level like teaching and the class, so might not be the universal solutions, but probably one of the challenging solutions. But for the like undergrad level or some of the more that deliver the general fundamental GIS, sorry, I have no good right answer.
No, that's absolutely fine. But yeah. we don't expect you to all be experts in every part of this. Definitely, I'm here to learn, and I've so far taken a lot of notes. Lilek, if you wouldn't mind if we go to you next to talk about quality in resilient GI science education. At the moment?
Sorry.
Yeah, no problem.
I do agree what Andrew explained, that we need to make quality metrics. And yes, that's difficult just because we know that the GIS is using by many specialties, from forestry, technical, and so on, so many. And then I think if we want to develop the indicator and criteria, it would be based on the background of the applications. For example, in IT, core GIS means that they're developing the spatial IT, and also its application would be different, the criteria of indicators, just because in forestry we need more like application, how to link, for example, with GIS, with for example, with other technologies, yes, so drones also, and also other sensors, and then we can make some, for example, forest 4.0 that work, yes, like this. very very precise for history. But in the other applicant is not. Yeah, that's is challenging how to develop such kind of crit indicator for the ensuring the quality of GIS. I think that's all, Merit.
Cool, thank you. John, I'm not sure I've made it to you for this particular question.
Yeah, a couple thoughts. One, in terms of a resource, is the Geographic Information Science and Technology Book of Knowledge that's been around for a couple decades. If you're familiar with that, one problem with the BOK or Book of Knowledge is that it's grown to be a massive document. And it's online, and it basically has everything that one would ever think ought to be taught or learned in GIS and technology. So it would be helpful if someone hasn't already done it to take a look at that and maybe identify benchmarks at different learning levels. So for example, a benchmark based on the BOK for first year introductory GIS course, second year, third year, post-grad, what the learning outcomes could be, and that BOK could be a resource for that. So that's one thought. One of the questions we were asked to think about had to deal with incentivizing teaching to the level that is equal to excellence that we're required to achieve in research. And actually, one way I think that could be achieved is to put more, is for institutions to have, to recognize publications in educational journals and journals of pedagogy more than they are. Because I think that we tend to try to aim for the high-ranking journals. That's what we're encouraged to do at universities. And those journals that are in education and pedagogy are not that high-ranked usually. And unless you're in a teaching only position, you don't have much incentive to publish in those types of journals. So our institutions could say, okay, once out of every 3 years, you should try and publish in a journal of pedagogy or teaching. So those are just a couple thoughts.
I'm going to do an unmitigated plug for the Journal of Geography and Higher Education at this point. Both myself and Amy are involved as editors, and GIS papers are very, very kindly received, and I think sort of very well read as well. But that's also, just to add to John's points, a particular resource in terms of getting up to speed. So what I'll do now, just because I'm also keeping a bit of an eye on the time, is move on to our final question, which means, John, you're on the clock again. It's to sort of, from here to look a little bit forward, and how can we future-proof GIScience education?
Okay, so just as a little bit of background, I'm now at Massey University, but before coming here, I was in Fiji, and there experienced Cyclone Winston as Winston came through, and as a result of that, we were basically teaching in a GIS lab, through a GIS lab, and we were unable to teach for 2 weeks. And occasionally, living in a country like Fiji, we were sometimes found ourselves without electrical power for a week. And so essentially things got disrupted, but none of that really prepared me for COVID and lockdown here in New Zealand a while ago, so earlier this year. Quite realistically, it was, I think, and I speak for everybody, that it was unprecedented how we had to deal with this particular disruption. So given the experiences that we had and the experience that I had, one of the most important things that I came away from this was that we need to recognize first that these disruptions are also disruptions to the lives of our students. I know that when we went into lockdown, my first panic was, how am I going to rearrange this class and still make everybody happy? And it actually didn't settle in until a little while after that my students were also panicking and they needed to be considered. So I do think that we need to recognize that if we live in a world where we might experience disruptions in teaching for whatever reason in the future, that we need to somehow remember that the students are also being disrupted and we don't know what they're experiencing. The other thing that I think is that one of the things we need to do is we need to plan for uncertainty. And what this involves is basically being flexible with what we teach. And some of this has already been mentioned today, but this means that we need to be able to look at our schedule, our curriculum of topics, and have a sense for which ones are really important or essential for that course and which ones are helpful and useful. And we may have to cull out or remove the ones that are just useful or essential. But I also have in mind which ones are really essential. What should they be leaving this semester with if we can't teach everything? One of the things I discovered in the lockdown experience was with regards to being flexible was that I actually was able to achieve something in a way that was unexpected. I ended up replacing one test with a project. And as a result of that, I felt like the project was a much better assessment than the test ever could have been. As students enjoyed it, and it basically met the learning outcomes that I wanted to achieve from the course. So being flexible to change an assessment such as a test for a project actually worked very well. So being flexible is important. I think this has also been mentioned also before, but not all of GIS science is software related. There's a lot of topics that if we, for some reason, are unable to teach with the technology, still can be taught and need to be covered, and maybe they're covered extra well. So for example, projections and coordinate systems. We could teach about practices of GIS, such as participatory GIS, the modifiable aerial unit problem, ecological fallacy, accuracy and precision. These are all topics that really don't involve software at all. And so if we run into a disruption of some kind, we can put the software learning aside for a week and focus more on one of these so that the students walk away with a really good understanding of projections and coordinate systems. And this way fills that gap that they may have had by not being able to work with technology for a period of time. Yeah, I think that's pretty much the thoughts that I had with regards to being prepared. And part of this is kind of an incremental form of contingency planning. If we're thinking of these things every semester, and now that we've experienced lockdown and COVID, we will be more prepared, and not in any formal way, but informally by always thinking about what's important, what's not important, what can be done in place of what, and then having an open mind to flexibility and how we go through our course. I think that's it.
Thank you so much. That's a really comprehensive answer, but I have no doubt that the different lenses we have on the panel, I was writing them down actually. We've got people teaching single GIS units, with people teaching GIS at undergraduate, at postgraduate. we've got different disciplines, we've got different career stages, and we've got different countries. So I'm sure so the rest of our panelists can sort of add to that, despite the fact that I can't think of anything right now myself. So is there anybody, I'm looking at the panelists, is there anybody who'd like to go first? Or, oh, will I start picking people? I think that's a bit of a hard answer to follow. Andrew, you look like you're happy to go next.
I've unmuted. I think one of the things that COVID gave here that was the biggest sort of side hit for me was students disappearing to different parts of the world, and asynchronous support, asynchronous marking and those sort of things. So, you know, trying to keep students engaged because, you know, people, particularly students who aren't computer science based or experienced, haven't done any programming, may not have installed software on a computer before, and typically use computing for consumption of content rather than creation, tend to get disheartened by things quickly. So in terms of, you know, the points about bouncing forward or resilience in teaching GIS, when we lose those connections, or those connections are quite tricky to make sure the students are achieving their learning outcomes. I guess, you know, there's only so much that you can give students as workflows or as, you know, content in a document that is of value. You know, at the end of the day, I think, as John was pointing out, spatial concepts, thinking critically in a spatial context about differences between process and pattern is, you know, not something that requires a computer, but is fundamental to the entire learning for GIS, I think, in order to make sense of it. I just saw a classic example of one of these on Twitter in the last week, where someone just highlighted a dockerless scooter company that had put in no parking and no riding zones, but that didn't include lakes and other things like that. So, you know, just this concept that GIS is a pair of attributes, an X and a Y coordinate in your data table, is quite problematic.
Cool, thank you. Just to point out to our panelists, Andrew, we've in the chat, we've been sort of asking about the Journal of Geography and Higher Education, and Andrew recently got a paper published, which is up under latest articles on authentic learning using mobile applications. So he's practicing what he's preaching. If we can move over then to Naru, if you'd like to sort of comment next on.
Sorry.
Oh, sorry.
As a shameless plug there, the app that's mentioned in that paper is free, ad-free, server-free. So if people want a GIS data collection app, it's available and works for both Android and iOS. So I don't make a cent off it. There's no ads, there's no fees or anything.
Thank you. It sounds like something we'll all have to check out. Naru, would you mind sort of commenting on the future-proofing of GIS education?
Yes, thank you. I think we can possible to teach to how to use GIS software like ArcGIS or QGIS, even the online or the to develop the techniques, to teach techniques to the student. But the most difficult point is to how to map or how to understand our nature or society from the real world, and then to represent the GIS applications on such kind of phenomenon. Then, yeah, we have a lot of good tools like QGIS or open data collections to get the data and software to teach students to how to handle with data, then how to map such kind of the data and spatial phenomena. But still wondering how we can teach how to represent our real world to the GIS applications, and that not only even the virtual environment, even in our face-to-face classes, it's still hard to teach how our GIS techniques can be useful for to solving our real-world issues. So probably our next target is how to teach such kind of our unique GIS problems to handle with such kind of problem. Then there will be a solution using the GIS science. So I'm probably it's not good answers, but my problem or my concerns about the GIS education is like that. That's me.
Cool, thank you. Lilek, if you wouldn't mind sort of speaking next, if there's something you'd like to add.
Yes, thank you. About the future of GIS applications, I think in the future, the connection of internet will be much better. And then I think there will be lots of data coming with different formats and with different size. And then most importantly, already there are so many applications that they can run in cloud computing. And then, for example, in our forestry conservation, it's like Condatis, like Maxsense, and others. Seems that we have to prepare such kind of condition that we have to teach the student how to use the cloud computing facilities, how to deal with such kinds of data, big data. So I think we have to move to prepare how the students can handle such kind of data. I think it's my question. Astos, thank you.
Thank you. Anisha, if we go to you next, if you'd like to add anything in terms of future-proofing GIS education.
Thank you. I think my response for that one will be more specific to our case here at CINU. I think like for our case, as John has mentioned, that some topics can be taught even without using softwares or stuff like that. But for our case, where we just did a single unit where we try to introduce GIS to that other fields, I think the only thing that we need here for expanding the GIS learning is we just need to introduce the GIS program for CINU. Yeah, I think that's it. We just need that program to be established here so that we have no problem with, and then from there we can see how we can future-proof GIS education, like more expanding from the program if we introduce it. Because now I think it will be difficult to tell the student about the GIS if we do not include the ICT technologies inside. Like it will be difficult for them to understand without sound and tangible evidence.
Cool, thank you so much. And just before we wrap up, is there anybody on our panel that would like to say anything about sort of the comments? I know we've kept to a sort of a fairly fast pace, working through quite a number of broad-ranging questions. But if there's something that's occurred to you that you wish you had said, please let me know and sort of make those comments now. You're all a lot more coherent than I am when I'm speaking in public, so that's fantastic. So what I'll do is, if there's anybody within our participants, with people who are listening in, any of our attendees would like to ask any questions, or if they'd like to comment as well on any of the areas that we've covered. You're more than welcome now to turn on your video, ideally, but definitely you're to unmute your mic and ask any questions. David's turned on his video, so I'm wondering if that's because he has a question. If he does, feel free to ask.
No questions, Mairead. Sorry. Just apologizing. This is appalling. I get up in the middle of the night thinking the meeting started at 4 a.m. Greenwich Mean Time. Check your time zone conversion. Massive apologies. Sounds like you've had a great meeting though so far. So I'm going to switch off now.
Thank you very much. So what I'll do then, I'll just give it one more awkward moment in case anyone feels that they need to fill the silence. It doesn't work. Maybe if I've told you, I'm going to make it awkward. Right. It doesn't look like there's anybody with any burning questions. I really would, if you have any thoughts and if you're attending the panel discussion, it'd be really wonderful if you could say them. I particularly thank you to Ari and Annette, who I've seen names pop up a few times in the chat. So on that note, what I'm going to do is just pass over to Amy, who is going to sort of summarize some of the things we've talked about today, because I think we've covered so much that I doubt you'll be able to get to everything, and just kind of wrap up the session for us.
Yeah, certainly. I don't think I could summarize everything, but I would like to thank everyone who participated in the polls and in the chats, because I think it actually helps us share more information. So some things that I took away from this, from my 3 pages of notes that I've taken, are that in some ways, despite the fact that we are all working in very different circumstances, and among the panelists, we have people who are working in full up GIS programs, we have people who are working in single standalone units, we have people who are working in places with great internet connections, people with not great internet connections. We have really a range of backgrounds that are among the panelists. But nevertheless, we're experiencing many of the same issues with students having trouble accessing the things that they need to actually undertake learning activities, with having to rearrange things at short notice because of disruptions of various sorts. So I guess it kind of goes to show that the more we think that we're not alike, we actually are really in the same circumstances. And I think we really can benefit from sharing things that worked well for us and our institutions and in our context, because there are, I think, some really great ideas that have come through. Like particularly, I was struck by the idea of loaning out portable Wi-Fi hotspots. Because even here, I mean, I live in one of the biggest cities in Australia, and you would think that we would have a proper internet connection, but we don't. And I was giving one live lecture this semester, and first my internet went out, so I tethered to my phone. Then my power went out, so I unconnected everything from my monitor so that I could open up my laptop and get back online. And then my battery went flat in the laptop. So even in places where you think you're prepared for every contingency, you're not. But the students were fabulous. They were in my live lectures, they were very engaged and were often chatting while the lecture was going on. And one of the students just started having conversation with the rest of the students while I was trying to get my power breaker flipped back on and everything. So I mean, I guess it just goes to show that people are inherently adaptable, and we just need to be creative and share solutions with each other on how we can solve some of these problems. There was at various points mention made of trying to have some way of coordinating that. And I think that is something that is missing. There are networks of people who try to work together in various parts of the world, like Naru talked about the Japanese network. There's in the US, there's UCGIS. In Europe, there's Agile. There isn't really one overarching global organization or anything like that. But maybe this is something that we could somehow work towards building that could be useful. And I think we had some great ideas today about things that could be valuable contributions to such a network, particularly the idea of trying to have a set of maybe general workflows that relied on a global data set where everybody could take data that was relevant to their context out and still, you know, basically adapt that exercise to their own circumstances. And while we often do that when we're looking for something and we find something online, it doesn't quite fit us, so we adapt it ourselves. Maybe you know, if we design it with that intent, it's easier to do that adaptation than it might be otherwise. So that was a really good and interesting idea. Let's see, what else? There were lots of things that I think were not just, one of the great things I think about today's panel was not just talking about the negative things that we have experienced, but also some of the positive things that have come out as a surprise. Like you had to change your assessment and it turned out to be a better assessment. Or the fact that when we are doing digital learning, we can see what students are doing in a way that sometimes is harder to see if they're not coming to class. So while in some ways I think teaching in a practical setting can be more challenging from a distance because you can't look over their shoulder in the lab and see where things are going wrong, and students may be hesitant to share their screen with you. So it can be very difficult sometimes to troubleshoot those things. We can also see when they're engaging and how often they're engaging in a way that's harder to somehow get insight into if they're not coming to your class regularly. So I take away that we had a number of, I guess, affordances that were identified as well as challenges that we face. So I think, you know, we will try and synthesize all of this. And also, there were 2 other panels that in different parts of the world that address these same questions. They've already been run. You can see the recordings for them on the website. I think Mairead's going to stick it in the chat window to give you the URL. But we'll try and have some kind of synthesis across all the 3 panels of what we've learned and gleaned from these global conversations. And then, you know, I think it's up to us as a community to try and find people to put their hand up to say, okay, we've had some good ideas. How could we actually move forward in a practical way? And maybe the next time we have a big disruption, it won't be so hard to deal with. Or the normal disruptions that do still happen, maybe we're better at dealing with them as a result of having lived through this experience. So I guess that is kind of what I can summarize in a semi-coherent fashion. So I might just leave it at that. Mairead, have you got any kind of last words?
I'm going to just pull out that disruption thing. Is we'll keep our fingers and toes firmly crossed that there's not another pandemic within my lifetime, and hopefully with all of yours, for those of you younger than me or healthier than me. But the thing is that I was involved with a piece of work a few years ago on disruption due to earthquakes, because New Zealand is very well known for its active landscape. And it's been really interesting to see the extent to which the lessons we were putting in place due to that type of disruption is actually relevant to this type of disruption. And one of the things that also sort of came out of that is that if you make your GIS education courses resilient, that's also resilient to disruptions in your own life. So for example, if you break a leg or, you know, if you turn up an hour late for a lecture, perhaps on a easier disruption note, that there are, you know, you have systems in place that actually allow you to be a bit more flexible than meaning that you have to be in a particular place at a particular time with students. For example, just even power cuts. So sort of there's a whole range of disruptions, and we're dealing with a massive global problematic one on so many levels, but also some of the things we're thinking through now may actually help us in sort of more mundane life disruptions. So I just wanted to thank everybody for coming along. Particularly thank our panelists who spent the time before this preparing and thinking through the different aspects, as well as obviously living the life in terms of resilient GIS education over the last year, if potentially further back in time than that. So thank you very much. Thank you all for coming. The video of this presentation will be available on the Implementing Resilience Education Panel 2 webpage that I've shared in the chat. And I'll also be emailing you a copy of that when it's available and when it's up online, as well as a summary and a transcript of the chat discussion. So if you have any concerns or queries, feel free to get in touch with myself or Amy. You should have our email addresses from the reminder email I sent out today. And I'm going to clap by myself because I can't think how else to actually do this, to say thank you very much to our panelists. You've been fantastic. Thank you all so much.
Thank you.
Thank you.
See you.
Thanks, everyone.
Fiora, bye.
Thank you very much. Bye.